Welcome to my channel. Your tutor Mariam is here. It's a sixth video of Introductory Physics 1 and the second video that I'm going to talk about the motion, which is the second subject in Introductory Physics 1. In this video I'm going to talk about the average and spontaneous velocity and acceleration. So if you guys new to Introductory Physics 1 and would like to learn more, I highly recommend you to hit the subscribe button, and also I appreciate it if you guys hit the like button too. It helps me to make more video for you. You ready? Let's get started. Alright, let's talk about the average and instantaneous velocity first. So let's say I'm gonna go for a vacation. Well, I wish I could, but I can't do this right now. But anyways, let's imagine I'm gonna go for a vacation and go somewhere, right? The first thing I'm gonna do is grab my GPS, and my GPS, based on the speed limit, gonna give me the arriving time, right? So what GPS calculate as a arriving time is based on the average velocity, right? Let's say I'm on the road and I'm driving so fast, and I just look at my speed meter. I'm like, okay, I'm driving so fast and I have to slow down, otherwise police gonna stop me, right? So at this point I'm reading the instantaneous velocity. Okay, that's a difference between the average and instantaneous velocity. So now let's look at some graphs in terms of the physics and see how we can calculate this. Let's talk about the average velocity first. I have my car here and I want to move it to the straight line, right? So the first thing I'm going to do is define my origin and also my x and y axis. As we talked in the previous video, the x and y axis can be defined in the different things. It can be defined as the acceleration, velocity, time, or position, right? So here I'm going to define this as a x and t, like a time and displacement. So because this is what we're looking for right now for the average velocity. If you haven't watched the previous video, I'm going to put the link below so you can go and watch it first and then come to this video. So for the average velocity, it's going to be delta v, which is equal to x2 minus x1 divided by t2 minus t1, right? So my x1, let's point it as the first position, gonna be 1, the second position gonna be 2, and my first position, the x and the time, let's write it down right here. My x1 and t1 gonna be let's say I'm gonna take the center of this card right here and the center of this car right here, right? These are the same car though. So my x1 and t1 gonna be 2 and 1, and for the second point I have my x2 and t2 gonna be 7 and 2, right? So now let's calculate the average velocity. My average velocity gonna be x2 minus x1, which is 2 minus 2, right? And the time gonna be 7 minus 1, right? So my average velocity gonna be 0. What that means? So don't be surprised here, because if I move the car in the straight line, the average velocity gonna be 0, right? And you're gonna see this a lot in your exam, because whenever you move something, it doesn't mean you changing the velocity. You might change the instantaneous velocity, but you're not changing the average velocity. Because in the average velocity, we're looking at the first position and the last position you have. We don't care about what's gonna be your velocity during the time you're moving your car, okay? How about if I don't move the car in the straight line? Let's calculate the average velocity for this case. So we know the average velocity, delta v, is equal to x2 minus x1, t2 minus t1, right? So my first position, x2, my second position, x2 and t2, gonna be 6 and 5. So it's going to be 5 and 6. And for the first position, I have x1 and t1. It's going to be 1 and 2. So my x going to be 2 and this one going to be 1, right? So for calculating the velocity, I'm going to subtract these two position and time. So it's going to be 5 minus 2, right? And then 6 minus 1, which is equal to 3 divided by 5, right? So my average velocity not gonna be 0 at this point. Let's calculate the average velocity for this car. So now my car is moving this way, right? Do I really care about this? Like, do I really care about the path is moving for the average velocity? The answer is no. So the only things I care is the first and the last point, right? So remember, for the average velocity, I'm going to say delta v is equal to x2 minus x1, t2 minus t1, right? That's the only things I care. So if I have the first position and the last position, then I can calculate the average velocity, okay? So I don't care about the path here for the average velocity. However, if I want to look at the instantaneous velocity, I do care about the path. So how it's going to work? For the instantaneous velocity is going to be the slope. Remember the first example I talked at the beginning of this video? So it's like I'm looking at the speed meter and then I'm going to read the speed at that time. That's the meaning of the instantaneous velocity. So what that means is like I can drive the slope of this path in each point. So that means the slope of a tangent line is the instantaneous velocity, and I can draw it everywhere during the path, right? Because we're talking about the instantaneous velocity. However, for the average velocity, we only care about the first and the last point, right? So the average velocity gonna be the slope of between the first and the last point we have. Let's talk about the average acceleration. So we know for the acceleration, the equation gonna be a delta v over delta t, right? Which is equal to v2 minus v1, t2 minus t1, right? This is a definition of the average acceleration that I talked about it in the previous video, right? So here, the only things is change compared to the previous slide, like the first example, is the y-axis. So here I have a velocity, which is v, in the case of the y-axis, right? In the previous slide, I have x as a y-axis, which is displacement, okay? So here you can see speed is not changing, it's always constant as 2, so then the acceleration gonna be 0, right? So how about the second example we wrote for the average velocity? So here again, I have velocity as the y-axis, right? So what I'm going to do for the acceleration is going to be v2 minus v1, t2 minus t1, and we know the answer going to be 5/3, right? How about the last example for calculating the average velocity? So here again, we're going to calculate the acceleration. So, and we don't care about the path. Still, we only care about the first and the last point, right? So the average velocity is going to be the slope between the first and the last point, right? And then for instantaneous acceleration is going to be the tangent slope, which is the point I'm going to choose. For example, if I choose the point right here, the instantaneous acceleration going to be the slope of the tangent. I'm really hoping you guys understand the instantaneous acceleration and velocity, and also average velocity and acceleration in this video. And if you like my video, please hit the like button and subscribe, and I'll see you in the next video.